like to talk to you today about nutrient application rates and field variability. If you put two or more farmers or two or more agronomists in the same room and argue about application rates, seldom will they reach a consensus on what the single best rate should be. And certainly there are calibration curves and science-based ways to determine that rate, but oftentimes experiences, acquired knowledge, personal biases, crop revenues, and beliefs all enter into the equation to modify those rates. One farmer might argue that 200 pounds is what he needs. Another might say 350 pounds before he sees an adequate response in his fields. And this, of course, assuming we're talking from the same point of view using a current soil test. So what is at the root cause, pardon the pun, of these varying results? Well, if we look at this table here, this is phosphorus soil test across the bottom in parts per million, and the OMAFA recommendation up the vertical axis to grow corn. And if we look at these different lines, they represent different levels of variability in the field. So if we look at 20 ppm on a uniform field where there's no variability, no matter where we test in the field, we get 20 ppm. The recommended rate of P2O5 is 20 kilograms. But if we did a site-specific sampling on the field and we found that the variability in phosphorus ranged from 5 to 46 ppm or 131% from the mean value at 20, then the optimum recommendation rate now becomes 50 kilograms of P2O5 based on the field variability. Potassium, same sort of thing. Potassium soil test across the bottom, 120 ppm on a uniform field, 20 kilograms per hectare K2O. That same field as before with 131% variability and K ranging from 40 to 200 ppm across the field landscape, but still averaging 120. Now the recommendation is 70 kilograms of K2O per hectare, almost 3 times that of a uniform field. So what's driving this is the more variable the field, the greater the response to nutrient application. And those high rates being applied to the low test areas in the field are generating enough revenue to justify that high rate to go on the whole field. So obviously the opportunity is there to be very site specific in our applications and put nutrients in the areas of greatest need and reduce application rates where we're in those non-responsive areas in the field. And this certainly has been the state of practice ever since our ancestors cleared the trees off the land. And over the many decades, our land management practices have served to amplify that variability in one way or another. So the next steps then are to determine the smallest area you're willing to manage. A composite sample represents 25 acres. And if that's your choice, then that's your management unit. You can't make nutrient decisions on anything smaller than 25 acres because you don't have information to do that. So if you choose to manage with greater intensity, then investing in the appropriate site-specific sampling program would be your next step. So whether it's grids of varying sizes or using stable zones created from yield maps or satellite imagery over a number of years, or looking at the current scanning technology such as soil optics to get at those management zones. Working with your crop specialist and putting it together from sampling to application using a digital ag software system that can track all this stuff from importing the soil sample to making the recommendation, making the application map, to recording the as-applied map to track all the activities is key to learning in this process. So regardless of the system used, a current soil test is required, nothing older than 4 years. That is a 4R certification requirement. And add in the sustainability factor, being able to reduce application rates on those high testing areas and reduce the risk of potential for runoff past the field edge has got to be one of the goals. So that's all for today. As always, thank you for listening, and stay safe and stay healthy, and there'll be more to come.